So hello and welcome to another video. We're going to be solving May-June 2024 paper 4-1 in today's video. Okay, so we did do paper 4-2 right after the exam series. So we're going to do paper 1. So here's question 1. Okay, so I'm going to go ahead and just open my File Explorer, and in my Visual Studio from my desktop, I'm going to go ahead and just bring in uh, this, right? Because the file wasn't found yet. Okay, from here we're going to create new question 1 underscore J24 Python file. Okay, and start working on our question. I'm going to increase the size just a little bit so it's easier to see. The program needs to take an integer number as input, stores the number, search for a specific number. So first we need to go ahead and do a global 1D array for data stored for 20 integers and a global variable number items. So for uh, data stored and number items, I think that's the name, right? Yeah, that's going to be 0 initially because we have no data. Okay, so the next question is initialize, right? So this is a procedure that prompts the user to put an input between 1 to 20, so we need to check that, and data stored. So we're going to do def initialize, and then these two are our global variables and arrays. So we're just going to do global data stored and number items. All right. Now it says it reads between 1 and 20. So we're going to do, let's say, while true for the validation check. We can do user num, and we take an integer as input, enter a number between 1 to 20, or 1 and 20, that doesn't matter. So if, okay, if user num is greater than or equal to 1 and user num is within our range, which is 20, that's when we break this loop, all right, and prompts the user to input each number and it's stored in data array. So now we're going to do for x in range user num. Then we're going to do array on array contents. You're going to take an integer input because that's the data type of the array. Enter the array data. All right, you can just ask for any input. And then in data stored, we want to use the append function over here and just put in array contents for this. And once you put 1 here, we want to also go ahead and increment the number of items to plus equal 1. That should be it for the first question. Now, the main program stores 0 in number items initialized. We already did that, and outputs the contents of data store. So write program code for that. Okay, so you want to call initialize, right? And then we want to go ahead and output the contents of data stored. So with that, we just want to go ahead and do print data stored. We could also just add, like, let's say array contents and then put data stored here. Your call. All right. So with that, we're going to test the program with, let's say, 30. Right? That's not correct, so we want to put 5, and then the program allows us to put the array data as a 3, 9, 4, 1, 2. And the array contents is, there you go, it is right here. All right, so very easy, simple first part of the program. All right, let's kill that terminal and then go to the next part. So we need to create an efficient bubble sort and do it in ascending numerical order. Now, the program doesn't specifically tell us to do an efficient version of it. You could just use the for loop version. So let's try to do that. So for I in range 0 to number items, or you could just do for number items for j in range 0 to number items minus 1. All right. And then we want to go ahead and do that if data stored j is greater than data stored j plus 1. We want to go ahead and do a swap. We can do data stored j plus 1. We swap that with data stored j plus 1 and data stored j. Like the contents of data stored j goes to data stored j plus 1. And that should be it for procedure for bubble sort. Amend it so it's called program and then output data sorted. Okay. So what we want to do is we want to go ahead and call initialize. We want to cut this from here. We want to go ahead and do bubble sort first and then paste this over here. Let's try to do the question for the following part. We've got 5, then we've got 3, 9, 4, 1, 2. So 1, 2, 3, 4, 9. There we go. Let's sort it in ascending order. Now, if you want, you could also do the efficient version of the bubble sort. This is like the most easiest and inefficient method with O log of n. This is not the efficient method, but we just want to get the exam done because they haven't told us to use any efficient algorithms. The function binary search takes integer parameter data to find the search for the array. And it uses an iterative binary search in here, so we don't need to do a recursive algorithm. So what we're going to do is def binary search. We can take data to find, that's I think the parameter name, data to find, there you go, that's the parameter name. Let's paste this right here. This is something that we needed. I'm going to put my Visual Studio to full screen, a bit easier to work with. Performs an iterative binary search. So once it's an iterative binary search, we can do the upper bound to be number items, the lower bound to be 0, right? Then let's say found is a Boolean value, which is false, and is not present, or just let's do not present be false as well. So while not found, so it's while not found and not present. Looks a little bit weird, but kind of works for the code. We want to go ahead and do the mid value, which is going to be upper plus lower div2. You could also use an integer. That's also like the int operator in this. So then we could do that if data sorted in the mid position is equal to data to find, right? Data to find. Then we could say that found is true. Else, if we see that data stored mid is going to be less than, let's say, our data defined, right? That means it's smaller than the defined. We want to go ahead and change the lower bound to search above the midpoint, right? So that's going to be mid plus 1 in this case. And finally, if that's even not the case, we want to also go ahead and do the upper bound mid minus 1. Now, if the data is not present in the array, we want to check that. You could also go ahead and put another and condition if you want to, right? So, and, oh, we've got 2 ands over here. So, and lower is less than upper. Okay? So let's just go and put that in this case. Once that's done, what we want to go ahead and do that if the question says that if it's not found, return -1. So if not present, Okay, that means it's not false. Then what we want to go ahead and do. Oh, so then we don't actually need this. If we were using another condition at the end of it, we would need this. So let's just remove this variable for now. So if not found, then we want to go ahead and do return -1. Else we want to go ahead and, because obviously we found, return mid. So that should do it for our binary search. So I'm going to take a number input from the user, call binary search with the number input and output the value. So amend the main program. So we want to go ahead and key bubble sort, because for binary search, it is necessary that the array is sorted. So you could use Python's built-in function. You could also go ahead and, oh, sorry, forgot to remove this. There we go. And you could also go ahead and use Python's built-in function. You could also go ahead and use, the bubble sort that you just created. That's more kind of accepted, that you use your own bubble sort algorithm. All right. So from here, let's say data to find. I'm going to use the Pascal naming convention in this case. So I'm going to take an integer input from the user so that the data types match. Enter the number to search. All right. And then what we're going to do is, let's call it X to store the binary search result. Okay, now what we want to go ahead and do is print. So if x equals -1, then we want to go ahead and print not found. Else we want to go ahead and just print index found and just return x in this case, right? Okay, so what we want to go ahead and do is, let's test with a given 5, 1, 6, then you've got 2, then you've got 8, then we've got 10, and then for 2, okay, so we've got a little bit of issue, not supported in instance of int, and oh wait, it's data stored. I didn't check it. Sorry, that should be data defined. Now let's try to do it again. That's going to be 5, 1, 6, 2, 8, 10, 2. Okay, 2 should have been found. That's strange. Okay, so and lower written upper, right? So but found is changed to found is initially false. Then found is changed to true. Okay. Then why is it returning the -1 if not found? Wasn't it being found? And lower is less than upper. Data defined. If it's equal to the found true. Else if data stored mid is less than, we do lower mid +1. Else we do upper mid -1, right? And then we check this, right? It does look correct to me. Let's try. Let's give it a try again. Well, not found. Yes. So initially it's not found. Uh, and lower is less than or equal to 2. Then we've got mid. It changes if and lower is less than upper. What if I do the less than or equal to? I have a feeling that might work. Sometimes that's, it might on the same position as like, the upper lower. 10 to, yep, there you go. So why did we need to do an equal to? Because sometimes, kind of the lower and mid, like lower and upper positions might be the exact same value. Like there's like after you shorten the array, you break down the array. So in this case, so if we do 5, then we've got 1, 6, then we've got 2, 8, 10. So if you break down the array, you've got 1, 2, 3, so you've got 5 positions, right? So it's going to be 5 divided by So that's going to be divided by 2. So that's going to give me 4.5, and we were using the diff operator, so you're going to get 4. So the mid position is 0, 1, 2, 3, 4. Right? So in that case, you're going to find, oh, sorry, 2. So 0, 1, 2. That's the mid position in this case. So 0, 1, 2 in this case. So 2, 0, 1, so 1, 2. If that's the case, oh, sorry, we're not working with the array. So let me try to explain this a little bit easier. Let's print. I just try to explain this array and print data stored. Okay, so now if we try to go ahead and do that, so we've got 5, 1, 6, 2, 8, 10, 2. So in this case, the mid value is 2, so 0, 1, 2. Okay, so then what happens? It becomes, it's obviously greater than, so it goes to only these two, being only these two. All right, so 2, 2. So the mid value is 0, 1. So it's on that particular position in this case. So if in that case, what happens is lower is less than or equal to upper. So what if it's equal to upper? Because at that point, lower is going to be, in this case, 0. And for the upper, like lower, it starts from 0 and then goes to 2. And upper is also 0 and then 1. So that's also technically 2 in this case. So we need to make sure that we put this equal to sign here so that it doesn't exit the loop before it kind of completely searches through all the elements, including when only 1 is remaining. Because if we actually go ahead and check that when you've got upper equals to 2, and then we do lower plus upper, which is 0 plus 2 divided by 2, you're going to get 1. So once we get 1, so that's going to be, kind of this particular position right here. 0, then a 1, right? So lower, at that point, upper is going to be just like mid plus 2, right? So upper in this case is number of items, which also starts from 0. So you should also do the trick here. All right, so that's how you kind of do this. Because sometimes, kind of lower and upper, like you have only, after you chop down the area, you only have one data remaining, only one value, one data remaining, right? So in that case, these two are equal. And that's also an area where we want to check if that only remaining element is going to be our actual, the one that we need, right? The one that we need. So in that case, we also need to go ahead and check lower equal to upper. So it's pretty important that we check that as well. I think the question also had another test case data, which is this. You got 5, then you've got 1, 6, then you've got 2, and then we've got 8, then we've got 10. And then what we want to go ahead and search for is 7, and there we go, 7 is not found. How exciting. So, oh, I think I copied Andy map right there. Sorry about that. Question 2 underscore J24.py. Now, for the next question, it is object-oriented programming. So let's go ahead and start it with this. So a class is tree in this case, and it stores data about tree. We've got tree name, height, max height, width, evergreen. A lot of information. So 1, 2, 3, 4, 5 data. So let's get started quickly. So class, this is tree. So let's do the constructor real quick. We've got init, self. You could also use the regular Python return naming convention. It totally works. I usually don't do it for CI exams, but when you're doing in a professional stand field, it's always important. You should do these. So, but your call. If you don't want to do it, that's totally fine. If you want to do it, that's also fine. The tree name, then I want to just copy this, height growth P. In your exam, you need to do a lot of typing P. Then you've got max width P, and we've also got evergreen. So evergreen P, right? Once that's pretty much done, these are all the constructor to its parameter values. So it gives you the parameter values. So now we got to go ahead and create self underscore. So we start off with, let's say, tree name. Then that's going to be tree name. Did I put two underscores? Yeah. Okay. Next we've got self underscore. Then we've got height growth in this case. So height growth P. Got max height. So we're going to do self dot underscore max height is going to be max height P. And we've got max width. So self dot underscore max width is max width P. And finally, we've got evergreen. So self dot underscore, I'm typing it, evergreen. All right. So this is the initial constructor for the very first program. All right, now we need to do a get method for all of them. Get growth, max height, max width, evergreen. So let's get to work. So def first is get tree name. And obviously this should have a self, or else it's not going to work. Then we want to do is return. The reason we need a self because everything in this class declaration is private. So it's within that class. So the self kind of shows that it's within the class, right? We need to use that self keyword, self dot get growth, right? So you're gonna go, oh no, right, height growth, def, then max height, this is also self, turn, self dot max height. Then you've got max width, which is also a self, return self dot max width, def self dot, then we've got evergreen. All right, so 1, 2, 3, 4, 5, 5 get methods. Wow. So now we need access to the text file. The text file stores data about 9 threes, and it's stored in the following format. So this is something a little bit new that they wanted to test in this case, which is how would you split something that you have got comma? Now you could go through each letter by letter through the entire string and do it, but Python has an amazing split function that we're going to take a look at in today's video. All right. I've heard that many candidates did go through the string line by line and then extracted it where it had a comma. That's fine, but that's also very lengthy and time consuming. And you need to kind of figure out some sort of algorithm that kind of starts after beach, then 30, then 40, then so you need another counter to kind of store the amount of letters that you've actually extracted. So very, very tricky. I wouldn't do that personally. Okay, so stores data about 9 trees. The data in the file is stored in the following format, and we need to go ahead and click on, create get data. So this is going to be outside the class, right? Or is it going to be inside? Creates an area of type. So this is going to be outside. So read data, right? And then you could use the width, like width this file as open. You could go ahead and do that. I personally wouldn't do that, but you could do that. It's totally up to you. You could also use the try method. So let's go and use trees as an array. Okay, and over here, what we want to do is it creates an array, reads data from the file. Let's just use the try except. Although it's not that efficient for files, like you need to remember to close the file, and sometimes you might cross errors. So make sure you kind of close the file, or don't forget to close the file actually. The file, let's go ahead and do open. So the name of the file is trees.txt, if I'm not wrong. So we've got trees.txt. Yeah, there we go, about 9 trees, right? And then we want to open the file for reading. Okay, so for x in range 9, because it's for 9 data, right? What we want to go ahead and do is we want to extract the file data file data. So file dot read line. So we want to take one line out, and then what we want to do is we want to go ahead and do name. Just create a few variables. So name, then we want to go ahead and create a variable for growth, then for height. I'm just naming them with evergreen. And on all of these variables, we want to take the file data and store the data by splitting the string where it has commas in it. If we had spaces, what we had to do is we had to do something like this, put a space and a comma. But in this case, everything is together. There's no spaces in between them. So keep that in mind. If you're confused during the exam, open the text file and have a look at it by yourself. You're allowed to do that, obviously, right? And then do the split command just like that in one single line. Okay, very efficient. And then in the trees array, use the append function, and then you put tree as the data type, and then put in the parameters. So we've got growth, height, width, and evergreen. So we've got 1, 2, 3, 4, 5. Make sure it's in name, growth, height, width, and then evergreen. So make sure the order is correct. And with that being said, outside the for loop, you want to do file close. Make sure to don't forget, except file not found error or file not error. You want to go ahead and do print, or we could just go ahead and do the return file not found. That's pretty much it since it's a function, right? And after we close the file, we want to go ahead and return trees. So this trees then has to go inside. We want to return trees. It's obviously going to return array, right? So return trees. You could also go ahead and put it outside the array. It shouldn't affect it, but since we're returning it, it's totally up to you. Okay. But we're going to see if it does put up a issue while doing it, then we're going to fix it later on. So the procedure print trees takes a tree object as parameter and outputs the tree's name, height, growth, maximum, and whether it's evergreen or not. And depending on if it is evergreen or not, the output is like it does not lose its leaf and it loses leaves each year. So you need to kind of account for that. And obviously it's normal to outputting it. So let's go ahead and do that. So print, does it take any parameter? It takes a tree object as parameter. So tree, let's just call it tree object. That doesn't matter whether it's evergreen or not. So once it takes a tree object, so if in that tree object dot get evergreen is equivalent to a no. Oh, sorry. Is equivalent to a no, because I think that's how it's written, right? The file, oh, it's a capital N. Why did I write NOS? Okay. If it's a no, then what we want to go ahead and do is print, and then let's start with tree name. So tree object get name as a maximum height. So just copy this for now. The object get max height, a maximum width, exactly how it is. So in this case, tree object get max width and rows. I think that's how it is. The object dot get growth, and then copy this. There you go. Okay, oh my gosh, it's gonna be very big. So let's just copy this. Then we want to do an else. Bring the same thing, but just change last Okay, so in this case, I think we need to change this to a yes, because the first thing is for an evergreen, and this second line is for not an evergreen. So just to change this, there we go. Right? I think that should do the job. So if it's not evergreen, it loses its leaves. If it is evergreen, it does not lose. Okay, great. So once that is done, the main program calls read data, stores a return value, print trees. The main program calls read data. So first, it calls for read data. Oops. And the trees being a array, we want to go ahead and store that. So that's going to be it. And with the first object of the return arrays, for the first object, and then it calls print trees with the first object. So we're going to go for trees. First object is going to be 0. Let's see. Okay, it loses 3 object, has no attribute. Get name. What was it? Oh god. Okay, so what we want to do is get tree name. Sorry about that. Really sorry about that. Hopefully it's gonna work now. There you go. Beach has a maximum height and width, and it loses its leaves each year. Let's have a look at beach. It's not evergreen, so it loses its leaves each year. Okay. Take a screenshot. Obviously, you're going to do that with evidence documents. We've got another question before, oh my god, before we can get to question 3. Okay. It's a pretty difficult paper, in my opinion. Okay, so the procedure choose tree takes an array tree. Okay, so def choose tree takes an array of tree. In this case, let's just name it tree. It doesn't matter. The procedure prompts the user to input their requirements for a tree. Okay, so in this case, this is for, kind of user. For a tree, the user needs to enter the maximum height, the maximum width, and whether they want it to be evergreen or not. If a tree meets its requirements, when it's not more than, okay, it matches their evergreen input and creates a new area of the trees. Okay, oh, nice. And then the print trees for each tree for the requirements. If there are no trees that meet the requirement at all, a suitable message is output. Okay, so you got a lot of work to do. So first, let's just call this array new tree. Okay, so this is the procedure. So we can create it inside the array, doesn't really matter, right? And then let's just call it the height that the user wants. Input case enter enter maximum height. Input enter maximum width, and then we want to do is evergreen is going to be input enter evergreen evergreen requirements. Okay, so once that is done, what we want to do is we want to go ahead and check that this trees array that we're doing, so for x in range, then we want to do is length of uh, trees, right? Yeah, for length of trees, got lots of similar names. That's not good for the program. So if trees x dot get, I think it's name get max height. Yeah, there we go. Get max height. Right? It needs to be kind of less than or equal to the user's height. And trees dot trees x dot get max width is less than or equal to height, width, and obviously we want this data to be integer. We want this data. Although Python does convert it, we want to be safe and just keep everything as integers, all right? Make sure you do that in the exam because I had faced problems like this. Fine, actually. Int width. And what we want to do is also check the evergreen requirements, right? So we want to go ahead and do that if trees x dot get evergreen get evergreen dot lower. We want to just compare everything in the lower section, right? Is in the user's evergreen dot lower when they're the same, right? Equal to what we want to do is find out what we want to append it. So in the new tree array, so new tree dot append, and then we want to go ahead and do trees x. That's the input array in this case. I'm going to make it a little bit smaller so it's a little bit easier for me to kind of code. All right, so that's pretty much it. So now we want to check that if anything was even added to the array. So if length of new trees or new tree is equal to 0, we want to go ahead and print a suitable message that not no matches found. And if it's the opposite, we found a few matches, then what we need to do, write a program. So let's see. The procedure choose trees needs amending. After the procedure is output the list of trees that meet the requirements. Okay, so we need to also output the trees that meet the requirement after this. So for x in range, length of new tree, what we can do is we can go ahead and call print trees in this case, and we do new tree x, all right? We also want to print trees that meet the requirement. That's just easy to do. So after this is done, we want to take as input the height when it's bought, take input the ones the user would like to buy from those trees, input the height when it was bought, and calculate out for how many years the tree would grow to its maximum height. For example, 40 centimeter when bought, beech, it's going to take 12 years to grow to its maximum. So how do you want to go and calculate that? You want to calculate that by looking at the time taken for its kind of how many years. So when beech was bought it was 40. So we want to do is 400 minus 40. All right. So if you go ahead and do 400 minus 40, so let's open calculator. All right. In an exam, just make sure to do it in a paper because you're not going to have a calculator. You're going to have 360. And then it takes 30 years for it to grow fully. So how many of 360 years? So you just want to go ahead and do a division divided by 30. That's going to give us 12 years. That's how you will want to go ahead and calculate, all right? So this is the procedure to go ahead and calculate. So you want to go ahead and now say that which is the user choice. So user underscore choice. And then we want to do is input, enter the tree you would like to purchase. Then we want to do starting height. And we want to also go to input, or let's just do it as an integer directly, right? input, enter starting height. Once that's also done, then we want to do is want to find that. So for x in range, since it's a class, like it's a class type, it's a user defined data type. We need to kind of search through the whole array until we find it by using, kind of a break command or something like that, or just go through the full array. Or else we could just do that for, or like you want to do that if this in this, we could do that function like where we want to find the first instance of that tree, but that's not possible because this is a class declaration, okay? But we could do that if you wanted to. So length new tree, right? So if user choice x, oh sorry, if user choice is equal to new tree x get tree name, right? Then we want to go ahead and do is choice underscore object is going to be new tree x. And then we want to break the loop because that's when we know that we have found it. Now, let's put another, so years to grow. Okay, so here's where we calculate. So choice object dot get max height. Okay, get max height. Then we're going to do is minus starting height. And let's just go ahead and divide it by choice object dot get rows. Okay, and we're using the div operator because we want whole numbers, so it's a lot more easier. Then we print a suitable message. So for example, using beach, the tree's height is 40 when bought, so we want to say the tree's height is, then we want to do is starting height bought, forgot the spelling of bought, bought the tree will take. So we want to put the variable in this case, which is going to be years to grow. Here's to maximum height of choice object dot get max height. Holy, that's a big piece of code. Now note that this it's an entire piece of, okay, great. So write a program to call choose trees. Choose tree is going to be getting ER. Let's see if we get any errors. Okay, till now we haven't got any errors. Let's see. You've got max out of 400, got max of 200, and the evergreen, the tree is evergreen, does not lose its leaves. So evergreen requirements, in this case, we're going to put in a yes, and we've got our first error. Did you mean get evergreen? Oh, great, great. Let's run it again. 400, 200, 200, want it to be evergreen. So we've got, in our case, we've got blue conifer and green conifer. From here, we want to go ahead and take it. Blue conifer. Sorry. So we want to take blue conifer and enter starting height as 100. And then, oh gosh, oh, starting, oh, okay. So starting height in this case is an integer, but this is a string. I forgot. So we want to do is do an int before it. So art 400. 200. Yes. Blue conifer 100. Okay, now what? Integer and oh, okay, I forgot all of them are strings. Int. Once more. Let's try 400, 200. Yes. Blue conifer 100. There you go. It takes 3 years to reach its maximum height of 250. Where is the blue conifer? Blue conifer is 40. If you want, you could also go ahead and do so. Let's open the calculator once again. So if you wanted, the maximum height of blue conifer is 250. So you could do 250 minus 100 in your example, and then divided by the 40. That's just 3.7. So we were getting around 3 years to approximately 3 years, right? If you wanted, you could go ahead and just do the singles. And I think the examiner, since nothing was mentioned, they wouldn't go ahead and deduct your. And I think it's a little bit more accurate to kind of give you the full decimal place height, uh, a little bit more of an accurate representation of the answer of how many years it's going to take. So that's our code for question number 2. Moving on to question 3 underscore J24 dot py. Okay. So question 3 underscore J24. Okay, so this is going to be the final question for the day. Okay. So Q stores a global 1D array. Okay. String values. It means space for 20 elements. Q head index the first, Q tail index the last. Okay. So what we're gonna do is the array name being Q data. Let's just copy it. Q data. It's an array for 20 elements. So we want to go ahead and do is Q head is initialized to -1, and both are initialized to -1. So Q tail is also -1. Okay. Now the next question is a NQ function, simple as it is. So def, we can go for NQ. And NQ functions takes data to insert as parameters. So we want to go ahead and do data to insert. All right. And we know that these are all global in our case. We're just going to do is global Q data, Q head, and Q tail. Once that's done, what we want to go ahead and do, that we want to check if the queue is full or not. So if you want to see that, we first want to see that queue size is 20, right? So what we want to do is if queue tail is greater or equal to 19, because it's starting from -1, so it's going to be like 0, 1, 2, so it's going to go up to 19 in this case. We want to go ahead and return false, right? Return false. Else we want to go ahead and first go ahead and increment qtail, right? So we want to do qtail is plus equal to 1. Oops, sorry. Then we want to put the data into the queue. So that's going to be q data qtail is going to be data to insert. And if the q head is equal to -1, we also want to go ahead and increment that to a 0. So q head will be plus equal to 1. And once that is done, we want to go ahead and return true. All right, that should be it for the queue. All right, now let's go for the dequeue function returns false. So this function returns false as a string according to this question right here, if the queue is empty. So what we want to do is def dequeue. We want to go ahead and take our globals. So if queue head is equal to -1, that means there's no data. We want to go ahead and return false. Else, what we want to do is we want to go for the another queue data. DQ data is going to be Q data, and it's going to be the first element in the queue, obviously. And then Q head is going to be incremented to 1 because it's a Q head, right? And then we want to also want to return DQ data. Okay, so the next way, this is interesting. Got a table of values. I think this is a check digit question. Yeah, this is check digit. Okay, the string value stored in the 7 characters long. The first 6 characters are digits. 7 characters, the check digit. The check digit is calculated the first 6 digits using the algorithm. So they've given you the check digit algorithm they calculated with. So multiply the position in 2, 2, 4, and by 1 in this case. Then over here for the 1, because the odd positions are multiplied by 3, and the even positions are multiplied by a 1. And this is a 7-digit check, a 7 character long thingy, and then starts from 0. So 6th digit is going to be the check digit, which is the 7th character. And we need to check up till the 5th characters in this case. So right here, they've given you an example that the check digit is going to be 4. It's in position 6, it's going to be 4. 7-character valid check if it matches. If it does not match the check digit for this. So in this case, if the 7th character is 5, it's invalid and it doesn't match. Okay, so the subroutine. Okay, so an interesting choice of word, subroutine. That means we gotta go ahead and implement NQ or DQ somehow into store items. And the subroutine can count the output as entered. Subroutine can be a procedure function as a property. It's up to you. How would you like to do it? So let's write the code and see how it turns out. If required, we'll do it as a function if needed. So the task is we need to first validate the input has a check digit removed and is stored in the queue using NQ. So each valid input has the check digit removed. So the check digit is removed and stored in the queue using NQ. Okay, so we also need to go ahead and remove the check digit. Okay, so how are you going to go ahead and remove the check digit? Okay, that's also pretty simple. We are going to go through how to go ahead and do that. Don't worry about that as well. So let's go ahead and get started. So def store items. So that's it. 7-character string input from the user. We want to put our globals, obviously. So now what we want to do is, and we also want to go ahead and the number of invalid inputs have entered. So incorrect inputs is going to be 0. And let's do a continued. So while, or let's say continue is true as a boolean. So while continued, user underscore dish. We first need to take the input from the user. So input, enter the check digits. Okay. And what we also want to do is take the, okay, so we also need to go ahead and in our case, also do a sum of the entire thing in here. So if you want to go ahead and do the sum, let's make a temporary array. Okay, and sum also being equal to 0. So for x in range, we want to go ahead and calculate from 0 to the 6. That means till the 5th position. If x, okay, so if x, where's the mod sign? There's a percentage in Python. So if x mod 2 is equal to a 0, that means it's an even position. So if it's an even position, we want to go ahead and do is temp int. Then we want to go ahead and go for a user digit x. So we want to convert it to an integer. And we also want to go ahead and multiply it with a 1 since it's an even position. And then in the temp array, we want to go ahead and append temp. If that's not the case, that means it's an odd position, and we want to go ahead and do the exact same code, but instead multiply with a 3. So for items in temp array, we want to go ahead and find the sum. So we want to do is sum equals sum plus items. So we were going to find the sum in this way. And then the check digit is something that we just calculated. Check digit str, because we need, and then sum divide by 10. And we also want to go ahead and round down. So the div operator does round down. So that's going to be a good thing. So we're doing 2, this is going to be 10, sorry for that. After that, if check digit is equal to 10, because we've got an exception here, that if it is 10, there you go. If the check digit is equal to 10, we replace it with an X. Then what we want to do is the check digit changes, sorry, not equal to, double equal to, changes to an X. Okay, so that's one if statement. Now, we want to go ahead and check that if check digit is equal to the user digit's last character, that's going to be a 6. That means a 7th position. Then we want to do is enqueue, call up enqueue, and then take in user digit. In my case, it was already a string, and then do this 0 to 5. Okay, 0 to 5. That's only going to store up starting from the 0th character till the 5th character. All right, so that's how you go ahead and specifically store it and remove the check digit. And else, if the check digit was wrong, what we want to do is print, let the user know that there was a check digit error. Check digit error. And we also want to do is go for incorrect inputs incremented by 1. Right? Now, after that's done, what we want to do is go for CTD and take an input from the user. Then we do y/n, easiest method. So if CTD is not equal to a y, anything other than y, that's going to be an n, obviously. CTD is going to be changed to false. What to do 2 is to continue. Continue. Since continue in Python is a built-in function. And once we get out of the while loop, we also want to go and print out number of check errors. And then we also want to output incorrect inputs. In this case, our program was a procedure since we didn't return anything. So that should do store items according to the entire question. We first went ahead and took an input, then we validated it according to the algorithm given, replaced 10 with an X if the value was 10, and then if it's invalid, we are not storing it in the queue. If it's valid, then we are storing up till an appropriate message is output if the queue is already full. Oh, so enqueue this, right? Also, okay, we've got so many x's. Let's just do I in this case. And then over here, what I wanted to also say that if I is equal to, so if not I, that means if I is false, print Q is full. Make sure to output that as well. All right, store items can be considered functions appropriate. If the queue is already full, subroutine counts validates its input using enqueue. Okay. Do we need to remove calculate gives, okay, the subroutine is summed from the input, validate each input, and the check digit is removed. So you also remove the check digit by doing this right here, 0 to 5. So I think we're done for this part of the question. Now it's call store items and then dequeue. So store items, and then let's try doing something. Okay, so the first input is this. Oh, okay, so Q tail. List index out of range. So something's wrong with Q tail. So we're incrementing this first. Okay, should that be a problem? That could be a problem. Right. Return false. Okay, let's put another statement. If Q tail is less than, we can go ahead and do less than 19, right? Take this. So again, one more else, and then we do this. It's a little bit inefficient, but I think it should work. Still list assignment index out of range. Okay, let's change this algorithm a little bit. Let's do it this way. Q data, this case, right? So what we want to do is if Q tail is less than, we have got Q size minus 1. Then what we want to do is we want to do the Q tail plus equal to 1, Q data being Q tail, data to insert, and if Q tail is a 0, then we go ahead and just increment. Or you could even do the Q head is equals -1, then just increment it by 1, that's it. Turn true. And if these are all not the case, then we just go ahead and return false. Hopefully this kind of works. Wow, we're getting the error, the queue's full. Okay. The queue size is, oh, the queue size is going to be 20 in this case. Let's retry. Okay, we're still getting list assignment index out of range. It's a little bit strange. Shouldn't be getting this. What if we do this as 19? Queue tail data to insert. So in this case, it's becoming out of range, right? Let's try to troubleshoot it step by step. So if Q tail is only less than Q size -1, we increment Q tail. Then we do Q data, Q tail, then we got to data to insert. Then if Q tail is 0, Okay, let's do one thing. Let's fixate this array to only being 20 elements. So for x in range, since we're not using the append function. And then do directly length of Q data. Let's I think it should work now. Let's see what happens. Oh yeah, I think it's working. Do you wish to continue? Definitely. Yes. So we were facing an issue with the size and the length of the cube, right? It's gonna go up. The screen's glitching a little bit in my PC, so copy this. Y. Okay, so you've got a check digit error. First check digit error. Paste this. Y 66. I think we're gonna get a check digit error for this one. There you go. Oh no. Here we want to go ahead and place Y, then place the check digit. Also got a check digit error. Y, yeah. Copy this. Y, yeah. Copy this. Y, paste. Check digit error. Don't want to continue. Let's see. There were 4 check digit errors. Wait a minute. Didn't I call DQ? I think I did. Oh, I forgot to. Oh no. Please don't tell me I forgot to print it. No, we gotta do the entire code again to test if it's working. Does the question tell us to output the kind of serial function? Yeah. All right, so let's do the program once again. Um, paste y, and finally paste no, and then yeah, there you go, just 9999 without the check digit, and that's the entirety of our code. All right, so I think we have done it successfully without any issues at this point. Um, with Q data, when you're just like doing QTail and that, you gotta go ahead and use the append function. So I think if we didn't do this, let's just give it a try for now, okay? To see if it works. And we're gonna do the length of the Q being 20 since we're already doing -1. And over here, what we want to just do is just do Q data dot append, and then we want to go ahead and do data to insert. I think this should work. Let's see. There you go. We have got a check digit error. Let's do the one which doesn't have error. Let's try this one. There you go. It's working now. So if you're using that, you got to use the append function because it's just a undeclared numbered of the array. All right. So that's pretty much it. And I'll catch up in the next video. Peace.